Hello, good morning, sir. My name is Jonas H. Dator, and here's my second report, torsional stress. What is torsional stress or torsional shear stress? Torsional shear stress or torsional stress is the shear stress produced in the shaft due to the twisting. The twisting in the shaft is caused by the couple acting on it. What is the couple? How can shear stress in the shaft be produced? Let's get into the subject. Shear stress in shaft. What is the couple? A couple is two equal and opposite parallel forces acting upon a body with a different line of acting point said as a couple. The following figure represents how twisting is produced when tightening of a nut with a wrench. When a machine members under the twisting force, then it is said to be the shaft is subject to torsion. Due to this torsion in the shaft, the stresses induced the shaft are known as the torsional shear stress or simply torsional stress. Torsional shear stress or torsional stress. So here's the figure. Consider a shaft is fixed at one end and another end is subjected to the torque as shown in the figure. As a result, each and every cross-section of the shaft is subjected to the torsional shear stress. Due to the circular section of the shaft, it has been considered that the shear stress at the center axis will be zero, and its maximum at the outer surface of the shaft. So from the torsion equation from a circular member is where T is the torsional stress induced at the outer surface of the shaft over radius of the shaft is equal to T or twisting moment of or torque over J or polar moment of inertia is equal to C or modulus of rigidity for the shaft material times angle or angle of twist in radians on a length over L or length of the shaft. Torsion equation assumption. This torsion equation is based on the following assumption. First, uniform material through the shaft. The material should be homogeneous, isotropic, and elastic. The second one, uniform distribution of twisting force along the length of the shaft. The third one, twisting force under elastic limit. The fourth one, the cross-section of the shaft is considered as the planar and circular both before and after twist. The fifth one, the distance between the two normal sections is the same in both before and after the twist. From the torsion equation, we can assume T over R is equal to T over J. We can calculate the torsional stress from this form. Same. And we can also find another unknown factor like the twist in the shaft, torsion force, or the polar moment of inertia from the torsion equation. So the conclusion, the ability to resist the torsion is known as torsional stiffness. The measure of the torsional stiffness is known as the polar moment of inertia. From this, the torsional rigidity can be defined as the product of the polar moment of inertia and the rigidity of shaft materials. Torsion rigidity is equal to C times G, where J is polar moment of inertia and C is modulus of rigidity for the shaft materials. And that's all, sir. Thank you. God bless.